So here I'll start with the 62.5%, and some of you might already know that this is same as 5/8, but if you don't, you just convert this into a fraction, and you will see how this will make things a little bit easier. 25 times 25, and then that's 40, and then divide by 5. So that's 5/8, which means that the area of these four triangles that are congruent, identical, is 3/8. All of these combined. So if I call this square to have a side of 4 by 4, which is 16, and I'm choosing that so that 3/8 of that, which is the sum of these four triangles, comes out to be a nice number. That area is 6, which means one of these would be 6/4 or 3/2. Now here, EB, if that's x, and then in that case, this would be 4 minus x, because this would be x. They're all congruent. And CG is 4 minus x. So that means that I can apply either the Pythagorean theorem or I can apply the area. So you could do the Pythagorean theorem as well. They both give you the same answer. If you apply the area, that would be the area of one of these triangles. So half base times height. Either one can be considered base and a height. So I get 4x minus x squared equal to 3. Rewrite this as a quadratic by moving it to the other side. And if you factor this, equal to 0. So x is either 3 or 1. But note here, they say CG is longer than EB. So x has to be 1. And then in that case, CG would be 3. They're asking for the ratio EB to CG, which is 1 to 3, choice A. You could also do it by Pythagorean theorem. I'll leave it that to you. So for example, if that's the area of the square would be 5/8 of 16th. So that would be 10. And that means each side is square root of 10. You can apply the Pythagorean theorem, which would be 10 is equal to x squared plus 4 minus x squared. And you'll see that if you plug in x equal to 1, this will indeed work. So you can also take that approach. Either way, the answer is A.